Okay, so this week's lecture, we will be covering lab 8. I know it's lab 9 documentation, but lab 8 and project 4, at least the setup of project 4. You've got a little over 2 weeks for project 4. It's due on like the 16th. Yeah, so about 3 weeks, almost a little less than 3 weeks would be a better description. And then for the lab, it's due next week, Monday. So like I said, lab 7 is coming back. You still have to deal with classes. This is such a big thing that like you're still working with what you got. So you can use the same thing that you've made from before. Like you shouldn't have to change the cow.java file. 4 things, you actually shouldn't change it. However, there is now going to be a dragon class and an ice dragon class. Again, same as last time, this lab is actually very short. The content of what you need to write is minimal. You just have to actually, like you have to know what you're doing in order to write the classes and stuff. So not much writing, but a lot more conceptual of a lab. There's not too many ways to get around doing the stuff you need to do. So like I said, for this lab, it's going to be the same thing. So you can just, I just opened it. There's also a fire truck going by. We love to hear it. So you can make the same thing as last time, just now you need 2 extra files. And then your main, you're going to just change that around to do a little extra stuff. So for dragons, if the cow object is a dragon, you have to add this little can breathe fire thing as well. Okay, close. I think I have like a cow. Yeah, cow heifer generator, and there's a new heifer generator as well. I'm going to refactor this. Yeah, okay. So now additionally with the main and cow, you got, I don't think actually main is what it's called, whatever you can submit to zyBooks. You now need to add new class, dragon, and new class, ice dragon. And so with both of these, honestly, once you get dragon done, ice dragon is a lot more straightforward. Like dragon, I would say, is the hardest part. But in here, some of the things you're gonna have to think about are inheritance. Can you see that, by the way, Ernesto? Okay, inheritance. How do you do it? The super keyword, it's got to go somewhere. What else is big? There's generally inheritance, super keyword, how do you do it? Oh, this is going to be in your main, so it's important to think about over here. But how to check the type of an object. We did that in the final exam, at least on the study guide. I didn't take a look at the exam itself. On the study guide, you had the one question of like how to check if Fuji, what class it. Oh shit, what did I just do? Yeah, there was like a question about how to check what class Fuji belonged to. So how to check the type of an object. Yeah, those are the 3 big things I can think of. Yes. Yeah, because can breathe fire for both things is very straightforward. And then here you're going to need to use the super keyword. Yeah. Okay, cool. Just kind of think about that stuff. While we're here, does anyone know how to actually inherit stuff? Can anyone type it out? Like, what do I do to make drag and inherit from cow. Ernesto in person says extend. Extend is the keyword, cow. So this, now it's math. So one thing you'll see here is that it says there's no default constructor available for cow. And if we do a little bit more work into this dragon, so the constructor we need is this was string name, string image. So here, oh. There you go. So it's got the string name, string image. If you hover over here, you'll say the same thing. It'll say there's no default constructor available for cow. And you've got a couple of options under here. There's insert super. There's add public no args constructor in cow. So we've got a cow, it added that. One more. What was the last one? Create constructor matching super. Oh, okay, so that's kind of, yeah. So with that, those are probably the main things you could think of doing. One thing to note is that the cow class will have all the methods down here. It should say the cow class should not have anything. Maybe that's in the previous lab. In the previous lab, we said that the cow class should not have anything but the constructor we put, so it should not have the default constructor. Where is it here? Yeah, so this method should be the only constructor for the class. There should not be a default constructor. So same thing here. So with the super keyword, do some fun shenanigans to make that work. So this isn't an error. Don't create a constructor, another constructor in here. You should not be touching your cow class anymore. Here, so that's that. Can't breathe fire, that's just a very simple return true. Here, this as well, again, dragon doesn't have a default constructor, but if you figure out how to get the super keyword to work with dragon and cow, this should be a lot more straightforward just because it's the same thing. Except with dragon instead of cow. And then here, this just returns false. And I think in your main, the big thing is like how to check the type of an object. Does anyone know the keyword for that? Not Ernesto. You already answered one. We talked about it in the final exam study guide. Instance of from John. Okay, so let's create like cow there, and be like var instance if var instance of dragon. Sure. There, so that's a check. Why is this mad? Var might not have been initialized. Oh, okay, sure. It was new cow, sure. Name. So I bet this is yellow just because there's no chance. Yeah. So this is always false. But you guys are going to be dealing with an array of cows, and your array of cows, you go here. 8. Yeah, the naming. Oh, this what? Why was mine lab 9? Whatever. Why was mine called lab 9 cache? Whatever. So in here you're getting a new heifer generator. That's not what I wanted. Heifer generator. And this heifer generator might make some dragon objects if it decides to load. I'm just going to download it. Oh, that's perfect. Okay, well, I can shove it over here still. So yeah, and here now sometimes we're creating dragon objects. So this might look a little confusing, but again, you don't need to like actually know what's happening here. Just understand that it's making some dragon objects. Okay. Cool. And then this would be how you'd check it. Right. Any questions on that? I know we just did a general overview, but hopefully there's nothing too crazy going on there. Okay. So then the next big thing we gotta do is the project. So I would say this week is a good week for the project. What are the coming weeks? What labs are we working on? We're near the end, I know that. You guys are almost done. Ooh, recursion. Okay, so that's a more in-depth one. Okay, that's just recursion again. So I don't think that's what. Time complexity. Okay, that's an annoying one just because, yeah. So the next two labs I would say are a little more intense, a little more involved. You might have less time during the week to work on the project. So I'd say this is a great week to try to get the project going, because really this lab hopefully shouldn't be, oh yeah, spoilers. I think you guys could already kind of spoil yourself on the title, not maybe the title, but like the recursion, searching and sorting algorithms is time complexity. So not that, I guess, but yeah, you guys will be fine. But yeah, this week I would definitely say is your most chill week. So I'd really use it to make sure you can get a solid start on this project. But right now, technically, all I've been told is to go over the setup. I probably can go over just like a basic code thing with you guys as well. Yeah, I'll do that. Okay, so to start this project, getting the code base, you're going to be copying the code from this GitHub thing, from this GitHub repository. Now, you don't actually, the only thing you have to do with this is just make sure you have Git installed, which we did for that other lab, so that should be fine. But then in here, you do new project from version control, and then you can just copy and paste the URL we gave you in here. Is there a copy link? Copy link address, sure. Paste, clone. This one goes fine. What? Oh, I mean to close whatever I just closed. Okay, whatever. I'll go here and then get this link. There we go. That must have been, yeah, this must have been a shortcut to it. Whoops. Wait, what did, hold on. I wonder what I pasted. That doesn't change. Weird. Whatever. Okay, whatever. Here, copy that. Oh, that is different. Weird. Okay. Copy that thing from there. So go to the link, go to the top right, code, copy this HTTPS link. Usually they're the same. You must have updated it. And then new from version control there. Oh, and you can also change where you save it. So I'm just shoving mine right in there. Please work now. Yes, awesome. Okay, so now it works. So from here, technically you can just run it if you really wanted to. You got all this stuff up here. So mine looks broken for some reason. Why are mine broken? I want human visual. Module not specified. Here, let me just try running it. But yeah, so I would go to human visual just to kind of see it going. Run it. What is it going to yell at me about? Fix automatically, sure. Oh God, it's installing some random shit. What are you installing? I wonder if that actually is going to fix the issue. Yeah, okay, that's what I want. I wonder what the other thing it was installing was. It's always good when a program installs random shit. You have no idea what it is. Okay, it looks like it's still chugging through something. I might have installed the wrong Java version. Yeah, that probably, yeah, because I installed 15. So it's doing the right one. There it goes. Why do I only have the debug option? It has just a basic run option. Oh, there it is. I wonder what debug was. But okay, so if you get it working, I am using my arrow keys. You can't see it just because you can't see me doing my arrow keys, but I'm using my arrow keys to move this little Pac-Man around. I am playing Pac-Man. So if you can do that, you've installed it correctly. As you saw, I fucked up a little bit by just having it exist, by not having the right JDK version. Sorry, I get a little in the zone. But there was an automatic fix thing, so that was fine. What you guys lacked, so that was me just playing it. That's not what you guys are going to be coding. What you guys are going to be coding is in here, the student attacker controller. So yes, in here is what you're controlling. So like this one, what is this doing? So the possible action true, possible action not true, get. So this is a random one. Okay, and this is, okay, that's a visual debugging tool. Okay, so this, the one we give you right here is just picking a random direction, and then this is showing you how to use some debugging stuff. I want test agent visual. Yeah, and test agent visual will run what's in here. So if I run this, it's taking a second. There we go. So the actual movement is just picking a random direction, but this little thing right here, which is putting a color on it. So it's gain a get attacker, add path. So this add path to method puts a little colorful path on there, which a lot of people find helpful to use as they're debugging to see like what you might use. If you're going towards a destination, you might add this to your with the destination node in mind. And that way you can see like where your character is actively going. So yes, this is a random example. One example I give students just because it does not work, like it would not give you full points, is generally like how to think about how to get to a location. So like, let's say for your code, you just wanted to go to the nearest power pill. So like if that was just the thing you started with in your head, you should go here. Oh, I want to be. Did I close that as well? Weird. I probably opened one of these. Okay, so in here, you have access to a ton of different functions. A ton of them. Those are just all the things we think you might find useful. But the way to use them might be a little weird to some people. I guess we could just start at the top. Hold on. Yeah, nope. So there's general ideas about the game. So yeah, it's Pac-Man. If a ghost eats you, you die, except they're not ghosts. Ghosts have a vulnerable mode so that you can eat them in that case. And then the score is just eating ghosts and eating pills gets you more score. Okay, here's a project structure. So the model, every update calls the update on the controller. And the update function on the controller right here is what we do in here. This update function, so it calls that. And it expects a number. And you give it a number. You can figure out what each of the numbers are, but I think it's like 1 through 4 or something like that. You generally won't work in direct numbers, but it does expect a number. And depending on that number, it goes in a certain direction. And that direction is then rendered in the view. So what you guys will actually be writing, like I said, it's in that attacker controller interface. Most of the stuff you'll be doing is in the update function. That gets called every frame of the game. There is, however, an init function and a shutdown function. If you would like to use those, init happens before anything, like the game even starts, before any frame occurs, and then shutdown happens after the game is about to close, like right after the game is done, right before it's about to close, shutdown's called. I've never seen anyone put anything in shutdown. I've seen some people put stuff in init, like initial locations of things, though it's still, most projects I've seen don't have anything in either of those, and they're just all in update. Update is definitely the big one. So yeah, when you're thinking about what you can do in this game, you should be thinking about what, like if you were playing Pac-Man, what would you like to do? That's how you should figure out what you want to do, because most things that you could do in Pac-Man, like if you're saying, I want to go towards a power pill, or like I want to sit next to a power pill before ghosts come to get me and then eat it right before. You can do that with these functions that we're about to give you, that I'm about to talk about. However, don't think about when you're actually trying to implement it, you should be thinking about what is true right now in the frame. You should be thinking about with their current location, what do I want to do? The current. Don't think about where you were going. Don't think about where you came from. You can implement that if you want to, but it requires a lot more steps to keep track of what was happening last frame or what's happening in the next frame. It's much better just to think about where everything is right now. So like the ghost actively is 6 spaces away. I don't care if it's running away from me. I don't care if it's going towards me. It is right now 6 spaces away. What do you want to do with that information? You can easily get that. So yeah, you can vary anything about the current state at each frame is very easy to get. So yeah, init, shutdown, sure, like we talked about that. Don't make your behavior random. You should be able to basically create a flow chart. The randomness will come from the ghosts and what they do. Here, like I said, here's all the functions. I just want to go through this first. Here's all the functions you have. One thing to note is that even though you have a get pill list function, a get power pill list function, and a check pill function, all this stuff, you can't just type out get pill list, like right in here. I could not. So what does get pill list return? It returns a list of nodes. So I couldn't just do list node variable equals get pill list. And it's showing it right there how you do it, but you can't just do this. That's not going to work. What you need is up here. So this is a game interface. That means that you need to call this function on a game object. So in here, when I was doing get pill list, it kind of cheated. And it was like, hey, here's how to do this function. It's game.getPillList. So game comes from a parameter of the update function. So right here, that's a game object. So you can do the game object.getPillList. Does that make sense? We did that with the cow class. Remember, you had like the get name, set get image. All of those things you had to call on a cow object. It's a lot like that, except now turned up to 11. Because once you've gotten this on these node objects, now so this is a list of nodes. So to get access to a specific node, you would do like, technically you could even do game dot get pill list dot get, and then this is an index, like let's get the 0th index, sure. You'd probably use a for loop for this. But now I have a node and I can call dot all of these functions on it. So once you have a node, you have access to all these functions to get the X position, Y position, check to see if it's a pill, check to see if it's a power pill, check to see if it's a junction. Junctions would be like any place where there's more than one direction to go. Check its neighbors, get a specific neighbor, get a list of all neighbors. Oh, this is number of neighbors. Okay. Get the distance between it and another node that you passed in. All of these are functions you have access to now when you call it on a node object. Same down here with maze interface. It has to be called on a maze object. You get the maze object from the game interface. There's get current maze. That's how you get that. So once you have the current maze, then you can call any of these on the maze object. And then the actor and Pac-Man are actors. So you can, oh, my internet connection is unstable. Hopefully it doesn't kick me out for a second. But yeah, if you get attacker or get defender or get list defenders, and you have multiple of them, you have to get a specific index. But you can call all of these, get location, get direction, get path to, get next direction, get reverse, get target, get target actor. All these things you can call on attackers and defenders. But then specifically attackers, you can call these functions, and explicitly defenders, you can call these functions. It's like, this is, if you wanted to figure out if a ghost was vulnerable or not, you could do like game dot get defenders, and then do a for loop for that to check each defender, and then on each defender object call is vulnerable in an if statement. So that would check, and you could do something. Yeah, stuff like that. So I highly recommend reading through all of these just to see what you have access to. There are some functions that aren't listed here that are in the game. They're definitely more niche. And I know one student found one from before that wasn't even implemented, so I would not use that since it wasn't even implemented. Because you should not change any code that's outside of the source folder, because you're only submitting the student attacker controller. You're not submitting everything else in here. So we're running that. So if it's not implemented, don't try to mess with it. So if you see that there's a function, like if you do dot something, if you do dot and you have all these functions, you're like, ooh, I want to try out I think all these here are real on the document. But if you see a function here that's not listed on the document, don't use it. Yeah. But definitely read through all these so you have access to. Okay. So once you see what you have access to, and let's say you've written something, you have all this stuff up here. You have example, human, test agent, visual. So all of those will actually display something. I don't know where example visual is. Hold on. I can probably find it. Example visual, edit. It's in game.executors. Exact, there we go. So in test example attacker. Example attacker is new devastator. Oh, okay. So that's a pre-compiled thing. Yeah, okay. So this is a pre-compiled thing. I would not, this is going to be more confusing if you look at it. Yeah, no. But get example runs a pre-compiled just example thing. So you can't like take code from it, but you can just still see it. If we run it, you can still see it. Then there's example and test agent scored. So human, there isn't one for these because scored literally just, it runs in the background. It doesn't display anything, but it returns a score. It returns what they got. So here's the example doing stuff. And then debugging, I think it just gives you extra debug information. I've honestly never used the debug configuration. Does it say in here what it does? Runs 5 example trials and saves the data about each game state to, okay, so there you go. It doesn't run as many trials, but it still saves information for you. But yeah, right here, this is the big one. Test agent scored is what we will be using to grade your thing. And when you see the scored version, oh, okay, so hold on. If we go to like test agent scored right here and run it, if you see a specific trial that you're like, why is that confusing? So what exactly are we supposed to be coding in the lab? Okay, so you're coding this update function. You're going to do a bunch of checks to see like, where am I? What do I want to go to? What are the ghosts doing? And based off of all the information you can get access to, you are going to decide the next direction that Pac-Man is going to take. And then you return that value. So most of the time, you're honestly going to be using, where is it? Get next direction right here. You're going to be using that. So returns the next direction the actor should move if approach is true, or flee if it's false. So you'll give it a node that you want to go to, and then to approach it true, and that'll return something you can store in action and then return action. So You're deciding what Pac-Man does, most likely using this. I don't think you should not be using direct numbers for this, but they are just represented as integers. Yes. Okay, so like Pac-Man movement, but we're provided the whole game. Other than that, yes, you're provided the whole game. You just can't manually move it. It's all autonomous. Honestly, so like you might be thinking like, how the fuck do I do this? The scoring, if you can, like I have seen it happen. It's rare, but I've seen it happen. If you can complete an entire level, like an entire single level, I think you're fine. I'm fairly certain that means you get 100% basically if you get the whole level done. Because yeah, to get maximum points in the performance category, you only have to get 6,400 points. If we run the human, I can play it for a second to see how much it gets, but you only have to get 6,400 points. So it's not like you have to play a perfect Pac-Man game. You just definitely can't do random. And if you have a simplistic behavior, if you have like a super simple behavior, it's probably not going to work. Eating ghosts is definitely a big one. So I try to like put something in your code to eat ghosts. That'll get you a shit ton of points. It is Gator Man. So oh yeah, actually we're eating like other schools or something, right? Yeah, that's valid. But yeah, I've already got like 2,000 something points, eating some people. Fuck. Whatever. You guys just watching me play Pac-Man. That's peak education right here. Yeah, okay. Okay, so never mind. It looks like completing a whole level isn't a guarantee, but it's a very good, it's still a great. Oh no, I lost. Oh no. Okay, well, almost a complete level. I got like 4,000 something. So if your AI is good enough to get to a second level, it'll probably do fairly well in a second level where there's resources everywhere again. So getting to the second level is honestly just the goal. I remember when I did this project, it was actually the reverse. It was us creating the AI for the ghosts. And basically the entire project was, how do I make sure that the Pac-Man doesn't get to the second level? Because if I could stop the Pac-Man from getting to the second level, that was a guaranteed A for me. But so yeah, you're trying to do this behavior. So yeah, you'll be delivering the student Pac-Man, but you're also delivering this other thing, this design post-mortem document. So 70% of the grade is your performance. 30% of your grade is this post-mortem document. Please, 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 for the love of everything holy, hit the word count. So it says 100 to 300 words. Please put at least 100 words. It says 100 to 300 words. Please put at least 100 words. If it says approximately 300 words, I'm looking for like 250. 250 to 350, but just approximately 300. Please, for the love of everything, put the minimum amount of words. Because if I see the minimum amount of words, it is literally just a straight, like that isn't a zero, but very, like I still also read it for content, but not putting the right amount of words is a big one that I see that it happens way more often than it should, even after warnings. So just hit the word count, please. The diagrams and description of attack behavior with methods with descriptions. So you do need a diagram. The diagram should be like a flow chart kind of thing. That'd be perfect. Just like when the update happens, where does your code go? Depending, what checks do you do? And then with addition to that, describe different portions of it. So like when you do a check for each node on your flow diagram, what do you describe what you're talking about? Why did you pick that? What tests did you do to figure out that that was a good thing to do? If you're using specific numbers for parameters, like what testing did you do for that? All that kind of stuff. Identification of successes and failures. That's like, as you're working on this, what really worked well for you? What went wrong? Did you fuck up something that took like halfway through the project? You had to change the whole thing. Did you never do that? Did everything work cleanly? Did you play some Pac-Man before you started and that helped? Did you play some Pac-Man before you started and that hindered you? Like what went well, what went wrong? Then a reflection on the project is different. Like what did you learn? How did what you learned be relevant for your future interests? What skills did you use while doing this? What would you have done differently? So the reflection on successes and failures, you don't have to say what you would do differently. Just a flat what went wrong, what went right, what went wrong. In your reflections, you could reference your successes and failures, sure, but just generally, like, what would you change? What did you learn? Like, how are you different? How are you a different person after doing this in the most simplistic sense possible is fine. You should definitely be able to come up with 100 words. You guys should be able to come up with 100 words on anything. I should tell you to talk about salmon right now, and you could bullshit 100 words out of your mouth. So please just hit that and then generally talk about this kind of stuff. If you have questions about, like, I know a lot of people are like, what's the difference between these two things? And I tell them that kind of thing. And then they just combine them together. And I'm like, no, please have 3 separate sections. This is not an English class. I'm not looking for creative writing. I'm not looking for uniqueness. I just want 3 sections, 100 to 300 words, generally about the concept. You're not sounding like a crazy person. Okay. Here's the grading. So postmortem document based on completion and quality. Completion, 100 to 300. That's the last time I'm saying that, but completion. And then I will be checking quality, reading through it, making sure you're not a crazy person. The agent performance, you can't get over 100%. So you have 6,400 points is the goal. That is the 100% A right there. But even though it's the goal, you can still get less than that and still be fine. Like a C isn't bad. So the thing that I showed, if you get to the next level, you definitely pass. That's true. But yeah, once you get to 6,400 points, everything else after that is just flexing. You don't need it. The test case, we show right here. If we go to example scored, sure, there we go. So it's going to run 100 tests after it finishes compiling everything. So I have never seen someone like do this and it be like wild. It's 100 tests. It's a good average. They're not all the same because the ghosts can be randomly different, but 100 tests is a good average. If for some reason, most of the time you get a score of 1, and then like every 1 in 1,000 games, you get a score of 10 billion, you would average out properly, but I would not recommend having something that acts that crazily, because then your average over 100 might not be accurate. If you're more consistent with your scores, then you'll be a lot better. Like sometimes you get like 7,000, sometimes you get like 4,000. Sometimes you get even like this, you get really lucky, you get to like 15,000. That's great. And then this is the average score. So the 6,000 thing is definitely possible. I've seen people get like 10,000. Some students like to be competitive with this. I know I definitely wasn't. I got my score and pieced out. But this is possible, and getting much higher than this is also definitely possible. So yeah, scoring, it's definitely doable. But again, you don't have to get the 6,400. That's just the 100% grade. You can still get 70% and be fine with life. Okay, so submission, a single zip file with the SRC folder and the PDF. So like in here, if I open in Explorer, Sorry, here's the SRC. I can move this Gatorator PDF into here. And then to zip them together, I left click, control left click to select both of them. So yeah, left click this one, control left click the SRC folder, or the other way around, left click the SRC folder, control left click P the Gatorator, so just a multiple select, and then right click anywhere and say send to compressed zip. And then from there you have to rename it whatever we told you to name it as. We tell you to name it. All right, we don't tell you to name it anything, so you can call it whatever the hell you want and then submit it. That's fine. But yeah, so submit this. And so in here, there's the SRC, and then your PDF that should contain everything right there. I will not be because since this is submitted through Canvas, it's not through Zybooks, so there is no test for it. I will not be taking anything for test cases. Don't ask. I mean, I guess you can ask, but I'm gonna say no. But if you want to ask me if your thing works, if this is a correct submission, I won't take it. You guys should be, you can test it yourself with the 100 test cases. You should be able to trust yourself that this is fine. I'm really not looking for like a detailed thesis. Hit that word count, and honestly, that's a lot of the grade. We hit that word count and don't sound like a crazy person. Okay, so that's the general overview. I'm gonna go over one little coding thing before I end it. Before I end the lab for today, I'll take any other questions about whatever. But any questions about the general overview we just gave? I know that might have been confusing. I highly recommend just reading through it yourself and then coming with more questions. You should definitely by next lab have read this over. Yeah, by next lab, if you haven't read this over, you're far behind. And then on actually trying something, I would recommend trying at least something, not something that's gonna be perfect, but just like playing around with it for a little bit for next lab. Okay, no questions. This lab's due in 3 weeks. Yeah, okay, I'll still show that. Okay, so with this lab, one thing that's important to note is that you're using a lot of functions. The functions are returning things. So you have to like be on your toes with that in a sense. So like getting rid of all this. To get access to the attacker, so if I just put attacker Pac-Man right here, that equals game.get attacker easily. But let's say we want to get the node that Pac-Man's at. So it'd be Pac-Man, Pac-Man node equals Pac-Man.get location. There. So like that's the way you could do that. Whatever setup you have here with like these multiple variables, another way you can do it is by just taking this part right here and replacing it there. Oh, crap. X, B. There we go. So you can combine function calls like this. Game.getAttacker.getLocation. Game.getAttacker returns an object, so that means you can call getLocation on that object. This can go even farther. Is pill or dot get path distant. What's a good one? Get neighbors dot get 0. Honestly, I think we could probably even use square brackets for this one. 0 dot, oh no, you can't use it. Okay, so it's dot get neighbors. That's the thing. So get 0 dot get neighbor. Like you can keep going with this forever and ever. Or you can just have a long string of functions. So anything list of node. So with a list, just any of these things that are lists, you can use a for loop to cycle through the list, kind of like an array. It's like in here, like for int I equals 0, I is less than game dot get pill list dot size plus I. There, so you can do it like that, just with for loops through lists like that. So yeah, any of these things, I keep closing it. Any of these things that return lists, just use get or dot size to use them like for loops. But then if they return an object, so like the attacker, defender, game object, maze object, all those things, then that's how you get access to the other stuff here, to these other functions, because you're calling these functions on that object. Just remember you have like a chain of stuff. Okay. That's all I'm going to do for this week. I'd highly recommend. So we only got through like half the period. Since that's all that it was, pretty short from what we needed to do. Really, just the setup was all I was supposed to do. Didn't have to go through all the talk up. But trying to like just mess around with stuff for a little bit, but you are free to go now. I'm gonna stop recording. Unless anyone has any questions. Assume not. Oh, we do have a question. What's up? Oh, project 3 questions. Okay, I guess project 3 was due Friday, which means you can turn it up to Sunday. Okay, so if people have project 3 questions, I guess we could take that too. But I'm gonna stop the recording if there's no project 4 questions. Okay.